Welcome to Data Minds. Today we're going to be dealing with analysis of variance, that is ANOVA. And ANOVA analyzes the difference between means of more than two groups. So if you have more than two groups, a group 1, group 2, group 3, or maybe group 4 or group 5, and you want to know the differences, whether the means between these groups are different or they're the same, then ANOVA is the best way to go about this. And note that ANOVA is used for what? More than two groups. So if you have two groups, you use t-test or z-test, depending on the sample. But if you have more than two groups, that is three or above, then you use ANOVA to analyze to test that sample. And so in this tutorial, we're going to take you through how you're going to test for ANOVA, and we're going to be using the inset space data, which comes with the R data sets that is inbuilt. So if you want to get it, so you just follow the commands through, and you get the same output. So the inset spray is already an inbuilt data set that comes with R. So to get that, I'm just going to run my codes over here. So if I do this, I have the execute function. I can decide to just place any of these over here, my cursor here, and press Control or Command Enter. I can decide to highlight the entire line as well, and just click on my run button here to run. So once I'm done, the run button over here is being done. I don't want to use the instance spray, so I'm going to name it. I'm going to let my data be equals to what the instance spray is. So that is done. And so I want to what to so over here I'm able to see this, and it's saying that it's a data frame. So the instance space data is a data frame with 72 observations and then what two variables or two columns. So you can see the rows over here are 72 and the columns are what 2. So we can see it over here using the view button. So and now over here, so we have the count over here, and then we have the spray. So it's like the spray, you have what you have different groups. You have the A, you have the B, the C, the D, the E, and then the F. So these are categories where we normally refer to it as K. So K in this sense is equals to what 6. That's the categories. And then when you come here, we know that what um normally the within groups, the between groups is normally what K minus 1, right? So that's the spray over here. So if you want to find the degrees of freedom for that, so you just put what? So it will just be what? K minus 1. And K is 6. So 6 minus 1 over here, you get 5 for the K minus 1. And N over here is what? Is 72. So you can see it down here. The N down here is what? Is 72. So you don't have to do anything. But you can also count it to see. You can also use the count to see the number that we have inside here. So I can decide to use the count. If I want to know what I'm doing, I can use the count. I'll just say count and I'll use my data. And I'll just highlight this whole thing and I'll run. And I see that what we have n equals what 72. That is the number of observations that we have in this data. And then to also get the within groups or the within degrees of freedom, that's going to be what n minus what k, and n is normally what the the entire what sample size, which is what 72, and k is what the category, which is 6 in this case. So if I have to take 72 minus 6, I'll get what 66 as my n minus k. This is just manually how you can calculate it, but the software itself will do it for us. So to normally get the R comes with this command, that is the AOV. The AOV is simply analysis of variance. So in this case, I'm going to put in my formula and then my data. My data is equal to the my data here, and my formula, I just want to know the count. So the count here becomes um, a dependent variable, and the spray here becomes what an independent variable. So over here it's like we are using this over here, where you have what this independent variables over here, which is the count and then the spray. And I'm going to set my data to be equal to what the data to be equal to what my data. So when I do that, I'll just click enter, and now you can see over here the software already. So the software will get you what the degrees of freedoms for all of them. So for the sprays, we have what 5 as the degrees of freedom, and the residuals, that's the errors, we have what 66 as our degrees of freedom, which is over here, which is over here. You can see it over here. But when you come over here, you can see that over here is like this, and here we have what 5 as this one. And so we have it here. But look at this, we have what the sum of squares here, and the sum of squares for spray and residuals is given. So we have the sum of squares which is given, and the residuals which is given. But we don't have what the mean sum of squares. We don't have what the mean sum of square for what for the spray, or you can say for the between and then what the within groups. And we do not have what the F statistic, right? So what I'm going to do is just what give a name to this. So I guess say my AOV to be equal to this same data. I'm not changing anything. I'm just going to name this to be equal to that, and I run this. Once I run, this entire thing is now stored inside the my AOV. And if I want to extract everything, I'll use the summary command. So if I use the summary command, I'm able to what to extract everything that I want. So I'll just use the summary and I'll click run. And once this is done, wow, it is now what over here. So you have the spray, and then you have what the residuals over here. The totals can normally come if you want to. So we have the degrees of freedom for the spray to be 5, which we had it to be over here. And we have what? The degrees of freedom for the residuals or the errors to be what? 66. So we have what? The sum of squares for the spray to be 2669, and that of the residuals to be what? 1015. We have the mean squared to be this, and that of the residuals to be this. And you know how to get the F statistic or the F value. The F value is simply what? The spray, the mean squared for the spray divided by the mean squared for the residual. So if you take 533.8 divided by 15.4, you'll be getting what? 34.1.7. And you can see that this is highly what significant. So because it's almost close to 0, so we can say this value here what they are highly significant. So this is how you extract values, or this is how what you compute ANOVA inside R. So now normally after every ANOVA test, what we try to do is do what? Post hoc analysis. And post hoc analysis simply tells us how far or the differences in what in the values you are dealing with. That is what we mean by what? The post hoc analysis. So you can normally do post hoc analysis after 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 you are done with your analysis of variance, then you do what? Your post hoc analysis. So I'm going to be using this command, the the Turkey HAD HSD. The Turkey HSD is also here. So that's the command I'm going to be using to what to be able to extract my post hoc analysis over here. So with the post hoc analysis, we're going to use that one. It is used to compare the the differences between the. So I'll just use this command over here. And once I'm done, I'm able to compare. So you have the B minus the A, the B minus A, the differences. You have the C minus the A, the differences, the D minus A. So it's going to give you the differences between what the various groups over here. And so you have the lower, the upper, and then what the P adjusted, right? So you have this is how you compute for ANOVA and post hoc analysis using what the R software. So this is the last code I'm going to do over here. So I'll just do it this, and wow, I'm able to extract this more or less like how you do for what linear regressions over here. So you have the spray B, and it's going to give you it's going to estimate the parameters or the coefficients for all what the variables. That is the spray B, spray C, spray D, E, and F, and we have the intercept. So it's more or less like a linear regression over here, and it's going to extract the coefficients for you, their standard error, the t value, and then what their probabilities over here. Some of them they are highly significant, some too they are not that significant over here. So this is how you compete for an ANOVA or analysis of variance inside or using R and R Studio. Thank you very much. If you haven't subscribed to this channel, please hit the subscribe button. And if you have a problem, please comment below and we will attend to you. Thank you guys very much.